Now, assuming that you've made all the proper underhood connections and you're ready to move on to the programming section, and you've got your USB cable attached to your computer and plugged into the interface harness on the CNG computer, we'll get started with the programming. First, we'll launch the software, and then it takes you straight to this, pretty much the home screen. And we have a 4-cylinder. This is an 8-cylinder kit that will do anything up to from 1 to 8 cylinders. So right away we have an error in the system, basically indicating that we don't have signal coming from 4 of the injectors. So start out, we're going to set the number of cylinders, take that down to 4, and now we can go in here and erase that error, saying that we don't have petrol injection on 4 of the cylinders. Alright, and now we'll go ahead and start the car up. And what we're looking for is injection pulse width on 4 of the cylinders right there, which we have, which means we've got signal from the injectors. And looking for a good tach signal. There you can see the RPM is 820. We'll rev it up to about 3 on the dash. It's indicating the right RPM is matching down here. If you are not getting a proper tach signal, there's a setting right here for RPM signal. You can set the voltage, you can play with that up and down, and see if you start to get a smooth output from your a smooth indication of your tachometer signal over here. Always rev it up to a higher RPM. Make sure that it's not jumping around or doing anything funny. This one's nice and steady. Usually if you attach on to the ignition coil negative pulse, there's not a whole lot you got to do here. Usually you can leave it in the default settings on single coil. 2.5 volts will usually give you a good tach setting. Now if you have to attach to something different, you're going to use the camshaft position sensor or the crankshaft position sensor as a voltage reference. You have a couple other settings you can play with. You can turn on the RPM from crankshaft sensor, and that'll allow you to set the amount of pulses that the wheel has per revolution, and you can play with that up and down until you get the right value over there on the tachometer. And you can also will typically have to play with the voltage whenever you do connect to a camshaft or crankshaft position sensor, because those are very low output sensors that are very sensitive. You can barely pick a signal up from them sometimes. That's why it's always best if you have just an individual ignition source or an actual tachometer wired to the cluster. You can use that as well. If you do can run into a situation where you have a jumpy tachometer signal, it's just periodically jumps up to a high value. Say you're idling at 800 RPMs and it spikes up every once in a while to some random high number, and no matter what you've done, you just can't get it to stabilize. You can turn on this RPM signal filter right here in this little checkbox, and that basically gives it just a little bit of a buffer to smooth out those spikes. But I wouldn't do that unless it's just an absolute worst case scenario there. Engine type is going to be standard unless you're doing a rotary, which is pretty unlikely. Lambda type, I do not connect this system to the oxygen sensors. It's really not necessary, especially if you're using the OBD interface to read the fuel trims directly from your car, which that interface we'll get into a little bit later. It's really not necessary for most applications. You do the tuning right on here, most of the time you're not really going to need that. Type of injection is going to be standard, and type of petrol injection is going to be standard on 99% of the cars out there that you're going to be doing a conversion on. The gas controller settings in the next tab. Switchover temperature. Now this is the temperature that the regulator is going to have to meet in order for the system to engage in Celsius. Typically around 38 to 42 seems to be a decent point. It all varies per each car, because while your engine's warming up for the first time in the morning, it's running a little richer than normal. and you don't want the CNG system kicking in during that time, because it's going to throw your settings aren't going to really match up in here with what it's trying to do, so it'll bog if it kicks in a little too early. But you obviously don't want to set it too high where you're driving 10 miles before the system kicks in. So there's a little bit of a balance. You have to play with that until you get it to a nice medium where you're not traveling too far before it kicks in, but it's not kicking in so early that it's bogging down before it gets up to temperature. And of course, once the car's started for the day, that temperature is going to jump right up and the system's going to kick in pretty quick. The switchover threshold right below it is the minimum RPM that will have to be reached for the system to engage. Now that is, I like to get a system tuned well enough that I can keep this to kick in at an idle. If you have one of those installations that no matter what you've done, you got your nozzles in the right location, you got your short, even hose lengths, you've done everything right, but it's just not very smooth whenever it kicks in at an idle, you can raise that up to 1500 RPM or so, and that way the engine has to be, you have to be underway or actually rev the engine, up to a predetermined RPM for it to kick in. And once it's under load or you're at a higher RPM, the engagement's going to be much, much smoother. But typically if you got your hose lengths right, your nozzles are in the right spot, everything's set up properly, and you got it tuned real nice, you can have it kick over at an idle and you'll just barely feel it kick in. Switchover time is the amount of time once you start the engine. Let's say that all the other parameters have been met, it's already warmed up, it's already at the RPM. This is the amount of delay between the time that the engine is started to the amount of to the time that it's going to engage the system. So because your oxygen sensors take a little bit of time to warm up, if it's an older vehicle it takes longer, you can set that as high as 25 seconds. If you've got an older oxygen sensor, most newer cars with the wideband sensors, you really don't need to wait a whole lot. They get up to temperature real fast. You can set that to 5 seconds or so, and it's usually fine. The cylinder switchover below that in milliseconds is the gap in between each cylinder as it switches over to CNG. So they're not switched over all at once. Each cylinder is switched out one at a time from gasoline to CNG, allowing for a much smoother transition. So that is, once it's started the process, that's the amount of time in milliseconds in between each switchover. So you can also raise that number up if you're having kind of a rough switchover on a certain vehicle, and that'll engage cylinder 1 and then a longer lag before it engages cylinder 2, and that can sometimes smooth out your transition. Most of the time, if everything's right, leaving it at 200 will be perfectly fine. Hot start is an option for the system to start on CNG almost immediately when you start it up. It will only be on gasoline for just a split second as you're cranking, and it'll go straight into CNG within just a split second of it starting. That works on most cars that I've ever tried. Once you got the tuning set perfectly fine, you can engage that and you start right away on CNG instead of having to wait for the switchover time, whatever that switchover time's set up to, or any other parameters that you've changed. Minimum gas temp. Now that is the rail temperature of the CNG injectors. We're not in a very cold climate we're at. I don't really have any problem with CNG injectors freezing over or anything like that, so I typically just turn this value all the way down. I have heard of some people saying, up in colder climates that the little injectors might be a little sticky, so you can set that to maybe -10, -5. Until there's some heat at least present in the rail coming off the engine that it's good for those injectors to kick in. Minimum gas RPM is going to be just exactly what it says, the lowest RPM that the system will stay on CNG. Now, the only time that you might use this setting is if you've got some engine. I've only had one, and it was an old EOBD F-150 pre-OBD that the mixture that the oxygen sensor was trying to achieve just wouldn't allow for smooth idle. So when the truck came down to an idle, you could set this to, say you set this parameter to 1,000 RPM, and anytime the RPM falls below that, it switches back over to gasoline, and it does it. If your tuning's set right and everything's good, then it will be seamless. You won't even notice it happening. That way it'll be idling on gasoline, but as soon as you touch the throttle and hit 1,000 RPM, it switches right back over to CNG. And if everything's set up perfectly, you won't even notice that that event's taking place. And that's the only time I've ever had to use that. Maximum gas RPM. Now that can be a little bit more useful. There are certain situations where you might be doing this on a very large engine, and you need a very high capacity flow. And at the higher RPMs, you're needing more than, say, 60 horsepower per cylinder out of the injectors. You've drilled the injector nozzles out all the way. You got your regulator pressure turned up to 2.5 bar, which is the maximum recommended pressure, and really it doesn't do anything turning it up higher than that, and the regulator's not intended for it. But still, at the upper RPM, you're leaning out, right before you hit red line. You can set that to, 1,000 RPM below red line, just wherever you're seeing your system lean out too much. You can set that there, and it'll switch over to gasoline once you hit that RPM. And like I said, if your tuning is real accurate, it won't be very noticeable once you switch back and forth. Now that's also another value underneath it, maximum engine load on gas. This also is, you can use it for a similar feature, that it builds a load value based off of your map sensor and your injection pulse width, that you can have it at a certain load value switch back to gasoline. Basically for the same situation that I was explaining. That's just another way of doing it. You can say, once you hit, based on this engine load over here, you'll be able to tell, roughly where you need to dial it in. Once you get past a certain throttle position, you need to kick over to gasoline, because you just can't flow enough CNG to keep up at a certain RPM or something like that. You can play around with that rather than doing it based on RPM. Now the pressure error time below that is the time difference that occurs whenever you have a dip in the pressure settings, that it falls below your predefined minimum CNG pressure on the rail. How long it'll allow for that dip below before it reports it as an error and shuts the system off. That occurs as you're running out of CNG. Basically, the way the system kicks out, if you have it set up properly, is it'll let the tank run completely empty, and depending on what you have the minimum gas rail setting set to, if it falls below that, it'll immediately switch back over to gasoline. And the way I usually set this is, say, this system, I believe I have set at 2.5 bar, which is the maximum. I would set that about a half a bar below your operational pressure on the rail. That way it allows for a little bit of room for it to dip, because when you snap the throttle open, it might fall a little bit, but you don't want it to allow for it to fall too much, or when it runs out of fuel, it'll wait a little bit too far along the process down to you've only got 50 psi in the tank, and the switch over back to gasoline will kind of wait too far, and you'll get a larger jerk as it switches back to gasoline. If you switch that to just 0.5 bar below your operational, usually you don't even notice when the switch over is went back to gasoline from CNG when your tank runs empty. You need to set these settings before you move along with any programming. If you come back and you change this number after you've done your tuning, it will affect your map points, the points for your tuning on the maps, and you'll have to readjust all that stuff. So make sure you set this up front, or realize that when you change this, you will have to go back in and make adjustments to that, because it's compensating in the tuning based on what you're telling it your operational rail temperature is going to be. The injector type is just a 3 ohm AC or GIAC. It's fine. The injector's heating is just a strategy for colder climates where you might have an issue with the injector sticking at a real low temperature. It'll drive a little current to the coils, not enough for them to open up the injectors, but just enough to build a little heat around the solenoids for a certain period of time before it kicks in to try to warm them up for you. I usually don't need that. Like I said, I'm not in a very cold climate where I'm at, so I don't usually have to engage that, because it also makes the switch over time a little bit longer because it's doing its thing there, for 10-20 seconds trying to warm those up before it kicks in, so your delay is a little longer. Now the extra injection switch off threshold, that's a little complicated. Typically you don't have to mess with that, but I would say maybe 1 out of 10 installs I do end up making an adjustment here. Basically what happens is you have a little strategy, kind of like priming in or an accelerator pump in a carburetor, a little strategy that's built into some cars' ECUs on the gasoline injectors that send this tiny little pulse before the main pulse of the injectors, and that pulse can be interpreted incorrectly by the CNG computer as an actual pulse, and it will cause a situation where you've just tuned and everything looks right, all your settings are proper, but when you aggressively snap the throttle open, you get about a half-second bog. And you can raise that number up. It's in milliseconds. Typically, you're not going to go over 3. Usually about 2.5 is where you're going to stop, because anything over that is going to be an actual injector pulse. I can show you a little later in the map what it looks like on the screen whenever you have this little blip in that extra injection pulse that you're trying to ignore there. But for the most part, you won't have to play with that. Reducer temperature sensor, it's just giving you different options there. The default, it'll say included, that's the one you're going to leave it on. The gas temperature sensor, same thing, CTO4, included in the kit. And obviously we need to change this system over to CNG rather than LPG. Now the gas level indicator, that clear gauge underneath the hood that comes with the kit, that'll be a 50K growing sensor. Set that to there, and you won't have to do anything else there. You can actually change these numbers if you'd like it to respond differently. This sending unit is pretty good. It's fairly accurate in the default settings, but you can go up there and actually correct those numbers at what voltage it's going to go down to the next dot on your little fuel indicator on the dash. That looks just like that. If you don't like what it says is a half tank, when it's down to a half, you can play with those numbers and get it to do exactly what you want it to do. But that sending unit that comes with the kit, and that default 50K growing, which actually I hit the 90K there. Can't see too well through the phone. 50K growing. And that's about what we've got. We got about 2,000 PSI in there, so it's about 3/4 full. And then exit out of there. And at the bottom you have your options for saving your file, or resuming your file, or taking it back to manufacturer settings. The advanced tab, for the most part, you're not going to mess around in here. Not going to need to mess around here too much. I'm not going to get into this. The video is already going to be fairly lengthy. So the only thing that you might set, if it's for a customer or something, you can set the allowed emergency starts, which is basically where you hold down the button on the switch over switch while you're cranking, and that'll actually allow you to start the vehicle directly on natural gas. You would only do that in an emergency situation where your fuel pumps went out or you ran out of gasoline and you need to start the car on CNG. If it's cold, it will start rough because it's in enrichment mode. But you can, keep your foot on the gas and just get where you need to go, at least for an emergency. You might want to just set that to 10. Just check the allowed box there and set that to 10 if it's for a customer, and because you don't want them just doing that all the time, because that's going to cause check engine lights and stuff like that because it's kicking in too soon, or a little extra wear and tear on the reducer because it's not got up to temperature. The diaphragms aren't warm yet and all that. So If it's for you, you can just leave that unchecked, and it'll allow you to do it however many times you want. And next step, we'll get into the actual auto calibration and tuning. Okay, now we're going to get into auto calibration. Let's assume that you've got injection pulse from all your injectors. You've set your reducer to the pressure that you want. Right here we're indicating it really high because when it shuts down it spikes a little. I've got this one set to about 2.4, 2.5, somewhere in that neighborhood. Your fuel rail's up to temp, your reducer is up to temp. We don't care about the oxygen sensors, we're not going to use them in this installation. You got tachometer signal, everything's good. Time to move on to your auto calibration. And hit the start button here. It's going to check to see your reducer temperature is above 50 degrees, and then it's going to start making some basic readings on the injector pulse type. And after a little while, you will see over here on the screen, you'll see your first gas injector turn on. Then it's going to sit there and play with that and try to get the injection pulse width to the correct value, just to determine what your baseline map should look like. During this, you want to make sure the car is at a smooth idle, all your options are turned off, you're not messing with the power steering, the AC is off. There you can hear the click of our solenoid kick in. And now we've got 2 of the CNG injectors firing. It's going to tune them a little bit, then kick them all in, and then it'll sit there and play with them back and forth until it's got the incoming pulse width for the injectors in the area where it's supposed to be. Now this process will take more or less time depending on how off it is, and I mean sometimes this can take a whole 5 minutes, and in this instance the whole process is going to be done in less than 1 minute probably, because it's dialed in fairly well and set up properly, so it'll go a little bit quicker. If you have your AC on or something like that during this process and the compressor is cycling like I just had after I told you shouldn't have the AC on, I had it on that whole time, that's why you saw the numbers going up and down. You're not getting a steady even pulse, so that process it's going to think it's chasing everything, going back and forth, and it'll take a lot longer. Now that basically adjusts your multiplier on the road is what you're wanting to get, and it'll also tell you to assign your injectors to their appropriate banks, and we'll get into that later. But that's a good sign. If you've reached that point and you get an error saying injector nozzle's too small or injector nozzle's too large, then you can either correct that with sizing your injector nozzles up or down, or adjusting your pressure up and down on the reducer itself until you get it to a nice level where your baseline correction is anywhere from 1 to 1.4 to 1, which I'll show you on the next screen. Because if it's too high, it's having to use too much pulse width to drive your CNG injectors at an idle. It's going to know whenever you really get up under heavy load, it's not going to have enough gas flow, so you need to size up. Or the other problem that you can get into is if you drilled out your nozzles too large, or you've got your pressure turned up too high, the pulse width at idle for your CNG injectors is going to be too small. They don't work properly at anything under 3 milliseconds. So if you find yourself when the system's kicked in, I'll go ahead and kick this back in and see where we're at. You would want this to be at 4 or above. On this one's idling with all the accessories off at around 4.2, which is good. If you see that down around in the 3 area, then you need to turn your gas pressure down or size down your nozzles just a little bit just to get that up in the 4s, because once it drops just down into the 3s or below, it doesn't predictably open the injectors. They kind of bobble and pop open at uneven rates, which will cause a rough idle or a surge in your idle, and that can be corrected just like I was telling you. Some engines, this is more of a critical adjustment. Some are fairly forgiving. You get up into the larger displacement stuff, I mean generally you're going to have the pressure turned up to 2.4, and you're going to have the injector nozzles drilled out and you're still safely up in the 4s and 5s. Yeah, like I said, when you're looking at that, make sure every accessory is turned off, because if you turn the air conditioner on, the compressor kicks in, the pulse goes up, and you're not going to be, because you're wanting to see what it's like under the minimum load of the engine, that it's still going to be able to predictably and smoothly idle. Next, we're going to turn the system back into gasoline mode. You can see down there it says petrol, and we're going to go over to the map tab. Now we need to drive the car and let it build its map for the gasoline injection pulse width. And what it's going to do is just gather, you need to drive, fairly consistently, but go up a couple little hills and do different load points, and you'll see this little dot, where you can see that represents going left to right the actual injection pulse width, and the height is your manifold vacuum. So that's basically a load value. So you're going to go around and drive, and it's going to collect data points and build a nice smooth line across there. And once that's done, we'll switch it over to natural gas, and it's going to build another line for you, and you're basically wanting to get those two lines to match up identically for most engines. There are a couple out there that in the upper load points, when it's in open loop mode, if you know what that means, that you may run it a little leaner in that range. But for the most part, you're just going to try to get those two graphs to line up properly, just almost identically. So basically, that'll tell you that your factory computer, the gasoline computer, is making very small corrections to how you've got it set up properly, so that you'll have smooth switchovers and not a lot of correction in your fuel trims. Because if it's off, that graph is off very much, you'll get some errors like system too lean, system too rich, because the fuel trims have reached their limit and it can't correct any further, and that means your tuning is not right yet. Well, now we've went for about a 15-minute drive and let it build its data points for the gasoline injector map. And now it knows what to expect. Basically, it needs this map initially to know at a certain load and a certain RPM what pulse width to expect in the way that it normally runs when it's on gasoline. So whenever we switch it over to run on natural gas, it'll collect another set of data points, and you'll be able to see the difference between the two and be able to make corrections. The system will make corrections, and you can also grab the graph and dial it in yourself if it's having a little trouble getting everything to match up perfectly. I would also recommend that during this process, if you don't have a scan tool, have a little, you can't really read the display too well on this one, but just a basic scan tool that'll allow you to read your data points. Specifically, what we're looking for is a long-term and short-term fuel trim, which I have set to the top there. We only have one bank because this is a 4-cylinder, so there's just a short and long-term. And you can see between the two, -11, -7, somewhere in that neighborhood, it's averaging -17 as an overall fuel trim. And this will just give you another way of seeing what's going on, because you want that value to be identical to what it's doing whenever it's on CNG, and you can make corrections on the fuel map. And it's basically doing that already through those two charts that we're going to see up here. It's essentially doing the same thing, but you have more of a direct readout through looking at your short-term and long-term fuel trims there. So if you're even at the idle, you really want to get this fine-tuned at an idle. I mean, I like to get them to the point where, you're within 1 or 2 or 3% of what it's doing when it's on gasoline and what it's doing on CNG. Because the closer you get that, the better your switchovers are going to be, smoother they're going to be. All the transitions, the better your tuning is, the more accurate it is. You're just going to have less stumbling and smoother switchovers as it disengages and engages.
at different points, because if the system kicks in suddenly or disengages suddenly and you have a 5 or higher percent variance, before the oxygen sensors catch that, they're not instantaneous, so before the oxygen sensors can catch that, you're going to have a little blip, and then it catches it, the oxygen sensor sees, and then they make a correction, and then it'll start to run fine. But if you really want to get it spot on, you can directly look at this number, or there's an option for an OBD interface that goes along with this kit that'll allow you to pull up right on screen, and it'll show you all your fuel trims. It'll show you all your error codes, things of that nature, and you can also leave that interface plugged into your OBD port, and it will make corrections on the fly. If there's a certain temperature that it got into, and your tuning it was off, it's constantly collecting data from your fuel trims on board. And if you have that interface, it also, whenever you're doing this corrections part that we're doing here, it does it more accurately. Instead of just off of the injector pulse width, it's also taking into factor your fuel trim corrections directly from the gasoline computer, and it'll get it more accurate. For the most part, you can get it extremely accurate this way. It may be easier for some people, and it may be a little bit more predictable if there's extreme shifts in outside temperature or something like that. It may hold it a little bit more accurately, but generally, if you get this part dialed in perfect, there's not too much of a need for that OBD interface. But it does make it nice because you can see the fuel trims and your air codes right on the laptop in the same software that you're seeing here. So now we've got the collection points for the gasoline. So now we're going to turn on auto adaptation, and we're going to run it on natural gas. And it's going to take some collection points and build a table for corrections on natural gas. Now it's taken those collection points that we had for petrol and used them to factor in to make a suitable corrections map for the natural gas, and you'll see that will disappear. It's basically absorbed those corrections that you saw from the chart that it built before, and now it's going to build a very similar chart, hopefully extremely similar, for the natural gas corrections. And then we'll get both charts up there. We'll go for another drive on gasoline after we drive on natural gas, so we'll have both graphs on the screen, and we'll compare them to each other, and then make some minor tweaks in if necessary, which there's always a little bit necessary if you want to get it really dialed in this grid right here. There are many other ways you can make corrections under more difficult to tune cars. You can go into different types of graphs and get really specific. For the most part, I'd say 95% of cars you can get it dialed in with just this screen. You can add in multiple dots here. You can right click anywhere in here and add in more correction points and manipulate these up and down to get your correction suitable. So let's go for about a similar conditions and similar drive on natural gas, and let it build its chart for that. Okay, now we've been out for a drive, similar driving situation as earlier, and gathered the data points, and now we have the green gas map. We had the auto adaptation turned on for this trip, and prepare yourself for a fairly powerless and choppy acceleration, because this is the first time it's going out on CNG. It hasn't made many alterations yet, so feather the throttle a little bit, kind of gradually get into it, and it'll be making corrections while you're driving, and get better and better, and drive it for a good 15 minutes or so, and you'll start feeling a better and better response as you move along. And now that we come back here, since the petrol map has been erased, or regular gasoline injector map, we can turn off the auto adaptation and go out for a drive again
on gasoline so we can have that map on the screen and compare the two. I've already got a pretty smooth idle, fairly decent response now towards the end of that drive, and I still feel like we can do a little bit better, and there's a couple flat spots in the acceleration. So now we'll go get that the gasoline injection map and compare the two side by side and make some manual corrections and really get it dialed in so we can get some really good response. Now we went for a drive on gasoline again, and you can now see the blue chart representing the gasoline injector pulse width and green graph showing the CNG injector pulse width. And as you can see, it got it pretty close. It's fairly drivable. Some people would probably even stop at this point, but if you really want to dial it in and improve the overall drivability of it and try to eliminate any possibility of system too lean or system too rich errors, now we can go in there and make some adjustments manually and make sure that we got it dialed in perfectly, and we're going to have good throttle response and drivability. So what you can do is take the yellow dots in the area where there are gaps, and you can right click on those anywhere on the red line to add in any other adjustment points you want, and move the yellow dots up and down to try and get the graphs to line up. Now you can see the green line is the CNG injection pulse width, and it's below the blue line because it's running a little lean. So in all the areas that we have a gap, you'll just go directly above that to the red line, get one of those little yellow dots, grab it, and use your cursor to go up 3 or 4 notches, and then drive it again for, say, 5 to 10 minutes, and you'll see the two graphs start to come together or go apart if you go the wrong way. And you want to get that as close as possible until you've got it driving as ideally as you can. And this is where we've ended up. As you can see, at the lower RPM range, lower load range, the graphs are pretty much laying on top of each other. And as you get to the upper load, there's a slight variation in there. And this is something that's going to be different for every different type of car where it runs the best. Once you get up to the higher load values, if you have the OBD interface for this kit, or you have a little handheld OBD scan tool, you'll probably see an area in there where you can see the engine go from closed loop to open loop mode. And what that is, it's changed throughout the years, and the newest vehicles don't even have an open loop mode. They stay in closed loop mode all the time. And in those vehicles, you're going to want these two charts to line up exactly. But in some vehicles that do still have an open loop mode, and older vehicles will go into open loop at even a much lower load, that's the opportunity that you have essentially to lie to the system and run it just a little leaner, because natural gas has a 17-to-1 perfect ratio, basically, or ideal ratio, where gasoline is more down around 14-to-1. So you can dial in a little extra power up there in the load areas where it's in open loop, because what open loop is the oxygen sensors can't keep up quick enough at high RPMs and high variations. So the computer ignores the oxygen sensor at a certain load value, and it just runs basically based off the mass airflow sensor and throttle position and a couple other sensors, and it ignores the oxygen sensors and goes to kind of a default value there. Well, once it's ignoring the oxygen sensors, it's kind of your opportunity to lean it out just a little bit, and you'll get better high load, high RPM performance as long as it's not monitoring in that area. And the later model cars that do not go into open loop, you just want it to match up perfectly, because it's still making corrections. You know, you can go 10% up or down, it's still going to see it at the oxygen sensor and correct it. So you just want them to be perfect. But
This car does have an open loop mode at high RPM, and it was, you know, still a tiny bit boggy whenever you floored it, so we had a little opportunity to kind of lean it out up there in the higher load areas and improve the throttle response and the power in that area. But that's just something you'll have to play with in your, you know, certain situation. Once you get the maps, you know, the map should be as close as all over as it is in the upper RPM range, just for you to get to a starting point. And you'll always at least 3/4 of the way up to the graph want it just as close as possible, and then you'll see on your scanner, you know, how hard you've got to press the throttle to get it to go into open loop and where that is on that chart. And then from that point forward, you can kind of just lean it out, just, you know, maybe 3 or 4%, and that'll just give you some better high RPM power and drivability.